In this video, we will discuss about the Fourier series. Before we continue, you must understand what is periodic signal and non-periodic signal. A periodic signal has the following characteristics. This signal repeats itself after certain period, and it keeps repeat itself over the time from negative infinity to infinity. Let's say at a particular time t, you measure the function ft to be this value. You see the signal repeat itself after one period. So p is the period. It is also called the time per cycle. When you measure the function at t plus p here, you found that this function has the same value with the ft. For the next period, you have the time plus 2p. So when you measure the function here, ft plus 2p is same with the ft as well. Therefore, we can use this formula to verify a periodic signal. So for a periodic signal, your ft will be equal to ft plus np, where the n is integer from 1 to infinity, p is the period. You can find the frequency for a periodic signal by using 1 over period. So for example, in this case, let's say the signal repeats itself for 5 seconds. Then this is the period, your p is 5. And if you substitute inside here, you obtain 1 over 5, which is 0.2 Hertz. Hertz means cycle per second. So if you obtain f equal to 0.2 Hertz, it means in 1 second, it rotates 0.2 cycles. Since we know for one cycle, you have 2 pi radian. Therefore, when you multiply 2 pi with the frequency, you obtain the angular frequency in radian per second. So when you multiply 0.2 with 2 pi, you obtain 0.4 pi radian per second. Sine, cosine, tangent functions are the periodic signal where all of them can satisfy this formula. You must know the important characteristic for the periodic signal, which is the ft equal to ft plus np. N is the integer from 1, 2, 3 and so on. P is the period. So for this wave, we have a sinusoidal waveform and it starts from 0. So therefore you obtain sine t plus 0 phase. So your function ft is equal to sine t. And the amplitude is given a here. So we can just substitute a into it. One cycle for this function is equal to 2 pi. Therefore your period is equal to 2 pi. We can substitute ft plus np, where your period is 2 pi inside. So you have to substitute the t equal to t plus n 2 pi here. So a sine, where your t replaced by this t plus n 2 pi. And you have to check your ft, which is the left hand side function, is it equal to the right hand side function here. So if these two are equal, then we say it's a periodic function. Let's check if the left hand side equal to right hand side function here. If they are equal, then we say this function is a periodic signal. Let's randomly choose the number a to be 5, t to be 6, and n to be 3, and you compute using calculator for the left hand side and right hand side. And you should get negative 1.397 for this case. If you try with other number of a, t and n, you will also get left hand side equal to right hand side. So we can say that this formula is valid, and therefore a sine t is verified to be a periodic function with period equal to 2 pi. If is given this formula, it shows that the sine t is a periodic function with 2 pi. Same with the cos t. So if this formula is valid, then cos t is a periodic function with 2 pi period. So in this case, you have the period equal to 10. So the frequency is equal to 1 over 10, and the angular frequency is equal to 2 pi f, which is 2 pi over 10. The general formula for the sinusoidal waveform is A sine omega t plus phase. So A is the amplitude. Let's assume amplitude to be 1 in this case. So omega is the angular frequency, where you compute it to be pi over 5. Lastly is the phase. So this is the initial phase at t equal to 0. So at t equal to 0 here, your phase is 0 degree. Therefore, you can substitute 0 inside. So after you compute this, you obtain the function to be sine pi over 5t. To check if this function is a periodic function or not, we can use this formula. Ft equal to Ft plus Np. So we can substitute the p period 10 seconds inside here. So you obtain this. So your function t substitute inside left hand side. You obtain this. And then Ft plus 10n. So you need to substitute your t function here to be t plus 10n. Let t equal to t plus 10n, then you obtain sine pi over 5. So replace the t with t plus 10n. Therefore, you obtain on your right hand side to be this function. You can check whether this formula is valid or not by substitute various t inside this formula. So let's say we choose the t to be 9. So substitute, you obtain the left hand side. Substitute t to be 9 here. And you can substitute any number from 1 to infinity. So by doing this, you should obtain the value to be negative 0.587 on both sides. With that, we verify that this formula is true, and therefore the function ft equal to sine pi over 5t is a periodic function with 10-second period. Non-periodic signal is the function that has no period. So for example, in this case, we cannot find the period because the signal doesn't repeat itself over time. For non-periodic signal, this formula will be not valid, and you cannot find the period because there is no period. Polynomial, exponential, log signal are all examples for the non-periodic signal. Let's try with more examples here. You need to retrieve these important parameters from the signal. So P is the period, L is the half period, P over 2, frequency is 1 over P, omega is 2 pi f. Then you need to write the mathematical representation for the periodic function. So if it's a periodic function, then this formula will be valid. If it's a non-periodic function, then it will be not valid. First of all, you have 5 sine t. So we know the amplitude is 5 and omega is 1 because the formula is A sine omega t. With that, we obtain this. So omega is equal to 1. Therefore, you can obtain the frequency equal to omega divided by 2 pi. So you can continue to obtain the period, which is 1 over frequency. Half period to be period divided by 2. The mathematical representation is this, where your ft is equal to 5 sine t on your left hand side, and your function ft plus np. So in this case, your p is 2 pi. Substitute 2 pi inside. Then you need to substitute t plus 2 pi n. T plus 2 pi n to the t function. So this is the formula. And this formula, if you check for various t, then you found that left hand side will be always equal to the right hand side. So this is important characteristic for the periodic function. And from here we can read it to be this function 5 sine t is a periodic function with period of 2 pi seconds. For the second example, you have the amplitude equal to 10, omega equal to pi over 5. So you can obtain the frequency to be omega divided by 2 pi, so you get the frequency. So period is 1 over frequency, then you obtain period equal to 10. Half period L is 5. So you can substitute the function ft on your left hand side and let the t to be this t plus np, where your p is 10 seconds. So substitute t plus 10 n inside here, then you should obtain this function. So from here we can say 10 cos pi over 5t is a periodic function with period of 10 seconds. In this case, you have a constant 7, so you see the function repeat itself for infinity time. So the period is equal to infinity. Since we know period is infinity, then half period will be period divided by 2. Infinity divided by 2, you also obtain infinity. So the frequency is equal to 1 over period. 1 over infinity, you obtain 0. So angular frequency, you also obtain 0. So remove this. This is not relevant. And the amplitude is the constant 7. Substitute the p inside this formula. Then you obtain the mathematical representation for the periodic function. So ft is equal to ft plus infinity, because substitute infinity inside, and infinity you still get infinity. So on your left hand side is 7. Substitute the t plus infinity inside the function 7 here, you still obtain 7. Therefore, this formula is valid and is a periodic function with undefined period. There is the period equal to infinity. And it's very important for you to understand, for a constant, the frequency is equal to 0. Why? Because the period is undefined, which is infinity. So the frequency is equal to 1 over infinity, which is 0.